All right, so you know that like I said, like I always say, the exam is fast approaching. So what we'll be doing now, we'll be taking care of questions. That is, if I start a topic, I will start from the questions they normally ask in the topic. So the topic is alternating current. So you know, what is an alternating current? An alternating current is a changing current produced by an alternating current generator. Okay, the generators, you know, okay, the ones at the generating stations, and the ones that you use, you know, sometimes in outdoor activities, or in your house. So now the alternating current, it describes a sine curve like this. Okay, this is the graph of current against time. So it moves, like it describes a sine curve because it's alternating. So the formula is I instantaneous equal to I maximum or I naught sine omega t. This omega is equal to what? 2 pi f. Okay, omega is equal to 2 pi f. Now there is also an alternating voltage. You know, current cannot exist without voltage. There is also an alternating voltage. They all have the same sine curve. So V instantaneous is equal to what? V maximum sine omega t. So this is the instantaneous voltage. This is the instantaneous what? Current. Now, like I said, I will first of all deal with questions, then come back and define some important terms in this topic. But you can also, you know, Google it out, you know, and you just know the definitions on your own. So what matters is you having the ability to solve the questions. Now, let us go. Now, the question says that an AC of 2.5 amperes, the current is what? I equals to 2.5 amperes of current, flows through a capacitor when a potential difference across its terminals is what? Is 450 volts. PD is 450 volts. Now, they say if the angular frequency omega is equal to 200 radians per second, 200 radians per second, determine is what? Capacitance. Now, you know, a capacitor also opposes the flow of what? Current, okay, in a circuit. So there's what we call capacitive what? Reactance. The capacitive reactance is what? XC. Just like resistance. Instead of calling it resistance, we call it reactance. Okay. So the reactance is given by the equation 1 over 2 pi FC. Okay. You know, a capacitor stores charges. Okay. From this equation, the higher the capacitance, the lower the what? Reactance. But the higher the higher the capacitance, the lower the reactance. Do you understand? The lower the reactance, the higher the what? Capacitance. Do you understand? The lower the reactance, see the reactance here. See the reactance. The lower the capacitance, the higher the reactance. Do you see it now? The lower the capacitance, the higher the reactance. The higher the capacitance, the lower the reactance. So they are related by, with this equation. So you know that from Ohm's law, we have that V is equal to IXC. This is coming from what? Ohm's law. You know, treat this thing as resistance, like I said earlier. We call it reactance instead of resistance. So now, using this formula, V equals to IXC. So what do we do now? You know, we are to determine the capacitance. So first of all, we find XC. Now XC is equal to 1 over 2 pi FC. So which is equal to 1 over 2 pi times the frequency. The frequency is 200. And no, the angular frequency is omega. You know, omega is 2 pi f. Okay, so this is omega. So this is omega. You see this 2 pi f here? It is what? Omega. So which is omega c. Okay, so which implies that xc is equal to 1 over 200 c. This is my what? My xc, which is what? 1 over 200 c. So now, remember we are looking for the capacitance. So now you know that V is equals to IXC. Okay, so my voltage, where's my 450? My voltage is 450. 450 is equal to, my current is 2.5, is equal to 2.5 times what? XC, which is 1 over 200C. You see it now. So we now have that 200C times 450 is equal to what? Is equal to 2.5. You see now. So which implies that C is equal to 2.5 over 2.5 over 200 times what? 450. So my C will become, let me get a calculator. So my C will become, and that is 2.5 divided by 200. That's coming. You have 200 times 450. We have 90,000. So it becomes 2.5 over 90,000. 90,000. So we now have 2.5 over 90,000. We have 2.7. 2.77. That's 2.7777. That is 2.78. Approximately 2.78 times 10 raised to power minus 5. Minus 5 farad. You know, capacitance is measured in what? In farad. Okay? Capacitance is measured in farad. So this is the answer. Okay? Yeah, this is the answer. So if you want to put this in microfarad, can it go? No, microfarad is mu equals to 10 raised to power minus 6. This is microfarad. So putting it in microfarad, think let's leave it like this. This is, I can put it in microfarad, but I don't want this video to be long. Like, let's leave it like this.